In this video, we will solve a problem on how to find out the points where the function has local maxima or minima. The question is the points at which the function y is equal to 2 times x raised power e to the power x has local maxima or local minima, or we need to find out the correct option as which of the following is the point where the given function is local minima or maxima. Okay, so what we have been given, we have been given the function that is y is equal to 2x e raised power x. Okay, how do we find out the local minima or maxima? So first condition is we find out the first derivative of the given function. Okay, that is dy upon dx. First we take the derivative of the given function with respect to x. Okay, since we have two functions here, we apply the product rule. That is, we write the first function as it is and take the derivative of the second function, that is the d upon dx of e raised power x, plus then we write the the second function as it is and multiply it with the derivative of the first function, that is 2x. Okay, so what will it become? This is 2x. The derivative of exponent e to the power x, it will be equal to e to the power x. Okay, plus we have e raised power x, derivative of x will be 1, so we are left with 2. Let's write this 2 here. So this is the first derivative. Okay, now to find out the local minima or maxima, we set the first derivative equal to 0, that is dy upon dx, and we set it equal to 0, which implies we set this equal to 0, which implies 2x e raised power x plus 2 e raised power x, and we set it equal to 0. Let's take 2 e raised power x common, 2 e raised power x common, we are left with x plus 1 is equal to 0. Here it implies either 2 e raised power x is equal to 0, it implies either 2 e raised power x is equal to 0 or x plus 1 is equal to 0. Or let us simply do one thing, divide both sides by 2 e raised power x. Okay, if we divide by 2 e raised power x here, 2 e raised power x here, so this term gets cancelled, we are left with x plus 1 is equal to 0, which implies x is equal to minus 1. This is the critical point. Okay, so first order condition or the first derivative gives us the critical points. Now to check out whether this point is the local minima or local maxima, we need to check the second order condition. Okay, second order condition tells us that we take the second derivative of the given function and evaluate it at the critical points. That is, we take d square y divided by dx square and evaluate it at the critical point, which is x is equal to minus 1. Okay, let's first take the second derivative of the given function. So we have, this is the first derivative. Again, in the first term we have two terms, we apply the what we call the product rule. We write the first function as it is and take the derivative of the second function, which is e raised power x. Then we write the second function, which is e raised power x, and take the derivative of the first function, which is this time 2x. Okay, let's write it here, 2x. Then we take, so this was the differentiation of the first term, plus we have the derivative of this function, that is d upon dx of 2 e raised power x. Let me see if I have done it correctly or not. So here we got 2x e raised power x, plus then we have e raised power x and derivative of 2 was okay, it is correct, which implies, let us rewrite it, we have 2x, derivative of e raised power x is e raised power x plus then we have e raised power x here, okay, and derivative of x will be 1, so we are left with 2, plus derivative of 2 e raised power x is 2 e raised power x, okay. So we have 2x e raised power x plus 2 e raised power x plus 2 e raised power x. Can we write it in this fashion? 2x e raised power x plus 2 e raised power x plus 2 e raised power x is 4 times e raised power x, okay. Now we evaluate the second derivative at x is equal to minus 1. Let's plug the value of x is equal to minus 1 here. So we have 2 into minus 1 e raised power minus 1 plus 4 e raised power minus 1, okay. If it comes out to be less than 0, then we have the local minima. If it comes out to be greater than 0, then we have the local maxima, okay. So let us see here. We will get 2 into 1 is minus 2. Transposing this, it will become e raised power plus 1. Here we have 4. Transposing this to denominator, it will become e raised power plus 1. So 4 minus 2 is 2. So we get here bases are same, we can add up the exponents. So let me write it here. So we are actually doing this stuff, d square y upon dx square, and we evaluated at the critical point x is equal to minus 1, and we got this very result, that is 4 minus 2 is 2, which is equal to 2 divided by e. Now you see that 2 divided by e is the exponential number, which is equal to 2.71 something. So 2 divided by a positive number will be greater than 0, okay. So when we evaluated the given function at the critical points of the second order derivative, its sign came out to be positive. So we can say the given function has local minima at x is equal to minus 1, okay. If the second derivative came out to be negative, that is if d square y upon dx square came out to be less than 0, then we would have the local maxima. Since the second derivative came out to be greater than 0, we have the local minima for the given function. I hope I make myself clear in this video. Thank you.